Okay, so I have some priority 1 questions to do out of section 2.1. Alright, and they are numbers 37, 38, number 11, 73, and 79. Okay, so let's do number 11 first. Okay, so we have number 11 out of the homework, which was find the derivative by the limit process of f of x equal to 7. So we know that the limit, that the derivative, I have to figure out how to erase here. I'm using new stuff, so let me pause this for a minute. Okay, I figured it out. If anyone's curious, I'm using Smooth Draw 3. Okay, and I figured out how to erase things. Okay, so number 11, it says to find the derivative by the limit process. So we know that the derivative, f prime of x, is equal to the limit as delta x goes to the value, right, of 0 of f of x plus delta x minus f of x divided by delta x. And we know that this is true for any function, but the reason that it's given in this form is so that we can use this definition for different functions that are given. So in problem number 11, our function is f of x equal to 7. Now it's curious when we have these type of functions that don't have an input variable inside of the function definition itself. So there's no x that's here. So we would say that f of 0 is equal to, it's equal to just 7. There's no place to input x into this. It's not really dependent on x. And so f of 1 is 7. F of negative 999 is 7. And it doesn't matter. So we also know that f of x plus delta x is equal to, that's also equal to 7. So f of x is equal to 7, and f of x plus delta x is equal to 7. So when we substitute these two values back into our limit definition, we get the limit as delta x goes to 0 of 7 minus 7 divided by delta x. So this gives us 0 over delta x. That would be the limit, the limit as delta x goes to 0 of 0 over delta x. So remember that the limit as delta x goes to 0 meant that we always had these very small values which were very close to 0, but were never actually equal to 0 themselves. We were just finding it as it approached 0. So that means that we have 0 over some very, very small quantity, but it's still not division by 0. So we get 0 over a bunch of things which are not 0, but it doesn't matter because 0 over anything that isn't 0 itself is 0. So the answer to this, question number 11, is the limit as delta x goes to 0 of the value 7 is equal to 0. And note that there wasn't anything really all that fantastic about the value of 7 itself, other than the fact that it was just some constant number. I could have replaced 7 with a bunch of c's instead, some constant value, right? I could have replaced it with 8s or 999s or whatever. Something that this shows us is that the the derivative of any constant function is always equal to 0. Okay, so next question was number 30.